Eclipse, it is important to always wear your Eclipse safety glasses anytime you look at the sun. Now, both types of eclipses are amazing shows, just with different perspectives. So today we're going to be bringing you views of the annular eclipse, and you're going to have an opportunity to view a total solar eclipse on April 8th, 2024. Now, Gina, anything you would add to that?
Of course, Tahira. So the science with the annular eclipse and the total solar eclipse, we can do great science, and NASA has a bunch of experiments, which you'll hear about later today.
Fantastic. Thank you so much, Gina. And folks, it's time to meet your other hosts. We have James Traley at our Eclipse desk. He's going to be keeping us keyed into the action, connecting with telescope operators across the country to show us live views as annularity sweeps the nation. And we also have Joy Ung and Michael Kirk at our Albuquerque desk. They're going to be joined with special guests throughout the show to talk about how important eclipses are to all the science we do at NASA and how you can play a part in the activities leading up to 2024's total solar eclipse. Now we're going to head out to Joy and Michael later, but first, James, how are things looking on your end?
Hey, Tahira, so excited to be joining you live from Kerrville, Texas. I've got my Eclipse glasses ready to view today's big event, the annularity, right here in just a few moments. We should be getting our first view from the West Coast in just a few moments. Up in Eugene, Oregon, they'll have the first awesome view from the United States. And you can track all of today's events using this interactive tool we've developed called our Eclipse Explorer. If you want to play around with this, go to go.nasa.gov/Eclipse Explorer. This is a fantastic tool that allows you to preview exactly what the eclipse is going to look like in your neck of the woods. You can see this path that it's going to be taking all the way down to us in Kerrville, Texas, starting out in the Pacific Northwest. But even if you're outside of that area of influence, say, for example, you're watching today's broadcast live from Milwaukee, you'll get a great view of a partial eclipse. And these little icons that you see here, these little googly eyes, if you will, they're actually clickable. So if I go to Eugene, they're supposed to have peak annularity beginning at around 9:17 a.m. Pacific. If I click on this little googly eye, it'll snap right to that time, and you can preview exactly where it's going to be. So you still have plenty of time to start getting up to speed with exactly what this annular eclipse or partial eclipse is going to look like in your neck of the woods. So I certainly encourage you to play around with this tool. And if we go to our real-time view of it now, you can see that a partial eclipse is already impacting a very large portion of the United States, stretching all the way out to as far as Nashville. And so very excited for our moment in this partially eclipsed sun here in Kerrville, Texas. We're expecting that to begin at around 11:50 a.m. local. I'm going to continue to track the movement of this annular eclipse across the U.S. But for now, back to you, Tahira.
Thank you so much, James. So excited to see that first instant of the Ring of Fire effect soon. Now, Gina and I are joined with Leslie Garrison.
Hi, Leslie.
Who is going to show us how to make a pinhole viewer to observe today's events if you do not have your Eclipse glasses.
Yes.
So, Leslie, I see you've got a few different pre-built pinhole viewers with you right now. Can you first just walk us through how this even works?
Yes, absolutely. So, to safely view the sun today, we brought a couple of items. We have a colander, a pinhole, a peg hole, a sheet of cardstock, and a hole punch. And so we're going to use them to simply create what we call a pinhole projector. And so in order to use these or to make these, you need a few items from home, but number one, make sure to never look at the sun directly, but number two, make sure when you are making and creating and using these that the sun is to your back so that the sun's light can cast light through the holes.
And you just, what, put it up and have it put a shadow on the ground?
Absolutely, and so on the paper model, we are going to put a hole here, and the light is going to go directly through it. Peg hole, the colander, and the NASA 3D printed model already has a hole. All you have to do is wait for the eclipse to happen and see the view of the sun on a surface area.
That's great. So, Leslie, can you go over those materials just one more time?
Absolutely. So at home, you probably already have a colander. This is just a pegboard toy from my son's toy box, and a sheet of cardstock, and a hole punch. But NASA has a cool event online. You can see our URL somewhere on our screen, and you can go online and make these items at home to use.
So really you just need something with a hole.
You need something with a hole.
That
the sun's light can shine through, so on the surface area, and you can see the eclipse on that surface area.
Simple, effective. Leslie, thank you so much for your help today.
Leslie.
And folks, this is a good time to remind everybody that it is dangerous to look directly at the sun without specialized eye protection for solar viewing during today's events. Now, we have a very special guest that you might recognize popping in to share some important tips to make sure that you stay safe during an annular eclipse.
Hi, Eclipse enthusiasts. Lance Bass here, and I want to tell you how to protect those eyes and stay safe during a solar eclipse. During these celestial events, the sun, earth, and moon are in sync, creating solar eclipses. During an annular eclipse, it's not the moment for a sun staring contest. Grab those eclipse glasses and shade your eyes from the ring of fire. What you'll witness is a true cosmic marvel. The moon will move between the sun and the earth, but the moon is a bit too far away from Earth to completely cover the sun. So, when you look up at the sky during this annular eclipse, you'll see the sun creating a glowing ring around the moon. Because the sun is never completely blocked, it is never safe to look directly at an annular eclipse without special eye protection for solar viewing. This I promise you. You should wear eclipse glasses so that you don't say bye to your vision. Seriously. And eclipse glasses are not the same as regular sunglasses. No, they're not. Safe solar viewers are thousands of times darker and will have a specific certification that you should look for right here. Don't be a space cowboy and try to look directly at the sun. If you don't have eclipse glasses, you can use an indirect viewing method, like a pinhole projector. You can make one of these with something as simple as an index card with a hole, or a colander, or even your hands. With the sun at your back, you can safely project an image of the sun through the hole onto a nearby surface like the ground. It's gonna be me who is wearing my eclipse glasses, and so are you.
Now, don't forget to be in sync with these safety tips, folks. Seriously, listen to Lance and protect those eyes. We really want everybody to enjoy today's events. Now, let's check in with Joy and Michael in Albuquerque, New Mexico. Joy, Michael, how is the energy over there?
Hi, Tara and Gina. The energy in Albuquerque is buzzing. We are so excited for the annular eclipse to pass through New Mexico in just under an hour. I'm joined with one of NASA's eclipse experts, Dr. Michael Kirk. Thank you so much for joining us.
Oh, it's an absolute honor and a privilege. I'm so excited to be here today.
So we're currently on the grounds of the Anderson Abruzzo International Balloon Museum in Albuquerque, and behind us, the Albuquerque International Balloon Fiesta is also happening. And in fact, a balloon is also about to get inflated right behind us, which is really, really exciting. So Michael, have you seen an annular eclipse before?
I have seen an annular eclipse in New Mexico back in 2012, but this is a special event here today. With the Balloon Fiesta going on, there are literally thousands of people behind us, all getting ready for this event. This is one of the most special eclipses I've ever been to.
This will be my first annular eclipse. I'm really excited, and the skies are looking really clear, so I have my fingers crossed that it stays that way. So we have these incredible balloons over the past week, but did you know that NASA also does science experiments and develops technology using balloons? They're slightly different from hot air balloons. So to learn more, I chatted with Chris Yoder from NASA's Scientific Balloon Program. Hi Chris, thank you so much for joining us.
Thank you for having me.
So you're part of NASA's balloon program. What is the difference between a NASA scientific balloon versus a regular hot air balloon?
Good question. So hot air balloons are air-filled, and the air is heated to create the buoyance through the lift that gives them flight. Generally, they float at a couple thousand feet, and they go up and down in a matter of hours. Scientific balloons, on the other hand, are quite different. So our largest balloons can fit a football field inside their equator, and they can fly for much longer. So payload capacity is about 8,000 pounds, several SUVs. The duration can be up to 5 or 6 weeks at a time, and the altitudes can be up to 160,000 feet, about 4 or 5 times the height of a commercial airliner.
Wow.
So quite a bit different, yeah.
That's incredible. And you launch all over the globe. So you launch from New Mexico in the US, New Zealand, and even McMurdo Station in Antarctica. Why do you launch from all those different places?
In short, we go where the science needs us to go. Some scientists need Northern Hemisphere science for galaxies and star formations. That's why we go to Sweden. Same thing in the Southern Hemisphere. That's why we go to Antarctica. Most missions need some kind of trial or test system. So they'll fly from New Mexico to prove their science or even just collect science at a shorter duration. And then for missions that are a little more risky, we'll go out to PMRF in Hawaii.
So can you describe to me what launch day is like?
It's an incredible feeling, right? So you see the balloon be released, you hear the rustle of the fabric and the rush of the wind as it stands up. You see the balloon be released on the vehicle and ascend, and it just gives you chills every time you watch it. It's a really great feeling.
That sounds incredible. So how many of these balloon experiments have been sun-focused or eclipse-focused?
So about 8 to 10% of our portfolio is heliophysics missions. One of the ones that stands out in my mind is one I got to see launch in 2019 from New Mexico. It's called the BITSI mission, and it was looking at the corona, or the kind of the outer edge of the sun, and looking at how that behaves under different conditions.
That sounds amazing. Thank you so much for joining us.
Thanks again for having me.
Our balloon program has been around since 1961, so it's no surprise that our balloons are constantly innovating and discovering new science. So let's dive into some of the big science discoveries that have been made with scientific balloons.
High above Earth's surface floats a critical tool in NASA's exploration arsenal: scientific balloons. Massive, helium-filled, high-tech balloons lift heavy scientific experiments into near space to get a clear view of our planet and the cosmos. Launched around the globe, these unique NASA missions provide a fast and cost-effective alternative to rockets to study Earth, our solar system, and beyond. Balloon science has led to many important discoveries. For example, astrophysicist John Mather studied heat from the early universe using balloons, which later contributed to his Nobel Prize-winning work confirming the Big Bang theory of an expanding universe. A special type of high-altitude balloon can carry telescopes above the clouds for extended periods of time to study the dark matter in distant galaxy clusters. One of these superpressure balloons, called SuperBit, captured the Tarantula Nebula 160,000 light-years away. This winter, crews in Antarctica are preparing to launch the Gusto mission. Its infrared telescope will examine the complete life cycle of a star. NASA's scientific balloon program, guiding a path to discovery above and beyond.
Joined with us now is the Balloon Museum Manager, Nan Maslin. Thank you so much for joining us on probably the busiest week of the year.
I'm so happy to be here with you all.
So we're here, the Fiesta started in the 70s with a small group of people, and now there are hundreds of balloons. Can you tell us more about the event and what it means to the city?
Absolutely. Well, it started in 1972 by a pilot named Sid Cutter, who had the idea to get a few hot air balloons together. He managed to get 13 together in a mall parking lot, and they expected a handful of people to show up, and hundreds did. And that's when he knew he was really on to something. And 51 years later, there's 100,000 people behind us on the field right now.
My goodness. So the Balloon Museum, it's where you work and it's where we are right now. Could you tell us a little bit about the relationship between the Balloon Museum and the Fiesta itself?
Absolutely. We are very good neighbors. We are here 365 days of the year. We started in 2005, and we start with the early ballooning in the 1700s up through today, exploring the history, science, art, and just wonder of ballooning. And if you haven't been to Albuquerque, we invite you all to come back and check out this museum.
And what do you love most about the Fiesta and the museum this week?
New Mexico is such an enchanting place to be, and the smell of roasting green chili in the air, there's nothing like it. There's a reason why Georgia O'Keeffe chose this place as her home. It's because of the open sky and the beautiful landscape, and we get to enjoy so much of that here. And when you think about it, there's like a spotlight shining on Albuquerque, and I think it's probably the best place in the whole wide world to be right now. Today, Balloon Fiesta and an annular eclipse. I can't imagine anything better.
And how do you feel about an annular eclipse falling at the same time as the event this year?
It's just fantastic. I'm so happy to be here with you all, and Mother Nature has provided us the perfect sky today. Looking this direction, I don't see a single cloud. There's a bite out of the sun already, like it's bitten out of an apple, and I just am so excited to see the annularity.
Amazing. Thank you so much for being with us today. I'm really excited to enjoy the annular eclipse together.
Me too.
So next, we are honored to hear from NASA Administrator Bill Nelson.
Hey everybody, we're so excited that you're joining us today for this solar eclipse. It's when the moon passes between the Earth and the sun. It's a big day for NASA scientists because eclipses present unique opportunities to study the sun. And what we learn from these eclipses, along with our heliophysics research, has incredible benefits for our human exploration. The sun is a powerful, hot, glowing ball of hydrogen and helium, and it actually holds together the entire solar system. Without its energy, we couldn't exist here on Earth. Just think, it influences everything. What we do on Earth, growing crops, our economics. It even affects our physical, mental, and emotional well-being. We see its influences reflected throughout our culture as well, in art, music, religion, sports. And when you look up today with your eclipse glasses, I hope you're going to remember all the ways that the sun impacts us. NASA will never stop studying our closest star for the benefit of all of us, terrestrial beings here on planet Earth.
Thank you, Administrator Nelson. So, Michael, we've been getting a lot of questions on social media. Shall we dive in?
Yeah, let's do it.
Okay. So, I have a question here from Priyesh Patel on YouTube, and they ask, do events like eclipses occur in a similar pattern geographically?
Oh, absolutely. Geographically, we get the same sort of shape of an eclipse that will move slightly northward in its progression. So this is called the Saros cycle. And every 18 years or so, there's a repeated pattern of an eclipse, and the pattern itself repeats a little bit further north each time. And so we get these overlapping patterns that are exactly the same over time.
Amazing. I didn't know that.
Yeah.
That's really surprising. Okay, and before I go on to my second question, I just want to mention that in the telescope view now, we are seeing a partial eclipse and a lot of bite out of the sun.
Oh yeah, it's getting a bit bigger. We're not quite to 50% yet, but yeah, it is getting there. It's pretty exciting.
That's so exciting. Okay, so the second question I have is Sammy Connor on YouTube, and they ask, how does the Ring of Fire eclipse affect the light from the sun reaching Earth?
Ooh, that's a fantastic question, because this has something to do with the science that we can do with eclipses as well. So as the sun gets blocked by the moon progressively, there are parts of the sun, active regions specifically, that will be blocked, and the light from the active regions won't be able to hit the Earth's atmosphere. So we can actually study the effects. We can actually study these effects. We'll hear a little bit more about this later in the program.
Amazing. Okay, so a third question is, one of our viewers on YouTube asks, how do eclipse glasses work?
Ooh, that's a great question.
So these things.
Yeah, we have eclipse glasses. Okay, so you see the lenses right here. This is a mylar film, and the coating on it blocks over 99% of the white light that comes here. Not only that, but it also blocks infrared and ultraviolet light, so it keeps your entire eye safe. So it's really that coating that keeps us safe from the powerful sun's light.
I'm glad.
Yeah, me too.
Thank you so much, Michael.
Of course.
So remember, wherever you're watching in the show, ask a question in the comments below using the hashtag AskNASA, and we'll be answering more later today. So now let's head back to Tahira and Gina in Kerrville, Texas.
Thank you, Joy and Michael. The weather looks great in Albuquerque, New Mexico.
It does, yeah.
So, folks, if you're just joining us, we're following the 2023 Annular Solar Eclipse as it sweeps across the Americas. Now, coming up soon, James at our Eclipse desk will be plugging us into our very first views of annularity taking place in Eugene, Oregon. Now, Gina, as we anticipate this beginning first moment, can you walk us through what exactly is happening when an annularity takes place?
Sure. So when the annularity is taking place, that's when the moon is going to be in front of the sun. Now for the annular eclipse, it's not going to completely block the sun, so we'll have that ring of fire that we get to see in the sky. And if you take a look at that live feed from the telescope that we're seeing right now in Kerrville, we already have a bite taken out of the sun from our perspective as well.
Wow, and so that's just going to pass directly over, but not fully cover it.
Exactly. We'll still have that ring peeking out.
Beautiful. And I mean, we're seeing something, but will anything else happen? Like, will we feel anything?
Yeah, so that's the fun thing about these solar eclipses is the fact that there will be environmental changes. So we'll feel that temperature drop, maybe a change in humidity and wind as well, but also nature will respond. So check out, how it feels around you. The birds will nest and go back to their trees. The crickets will come out, starting to chirp. It'll feel kind of dramatic when this happens too.
Can't wait to feel that with you today. And folks,
great.
I mean, it's not just us here on Earth plugged into today's action. Emily Ferfaro with NASA Communications had a chance to chat with 2 astronauts aboard the International Space Station to learn more about the sun from their unique perspective off our planet.
Jasmine, Satoshi, this is so exciting to be talking with you. This is the coolest thing that I've ever done. As you know, all eyes are going to be on the sun on October 14th as we experience an annular solar eclipse. And so I'm wondering, have either of you ever seen a solar eclipse of any kind?
Emily, actually, coincidentally, my very first day at NASA was August 21st, 2017. Which was an incredible solar eclipse. All my classmates and I got to go outside and stare up with everyone. Pretty much everyone else at NASA was outside in those moments looking at the solar eclipse. So that's something I'll always remember.
Wow, oh my gosh, what an incredible first day that must have been. Solar eclipse events provide scientists with a unique opportunity to study the sun in different ways. So with that, I'm wondering, how do you study space weather and impacts from the sun on the International Space Station?
Well, Emily, from the International Space Station, we have a really unique vantage point looking back at the Earth. But also there are several experiments actually mounted right outside here on the Japanese experiment facility outside of the GEM module.
Regarding the space weather, specifically from solar flare activities point of view, a specialists on the ground kindly observe it continuously, and when there is a big solar flare, they notifies it of us, and we move to a relatively safe place on the International Space Station.
Wow, I am so glad that you're well protected up there on the International Space Station. I want to touch back on the annular solar eclipse. This celestial event kickstarts NASA's Heliophysics Big Year, which is a global celebration of sun science and a year where we're inviting the public to do as many sun-related activities as possible. And so I'm wondering, what is your favorite thing about the sun?
Well, Emily, for me, I don't particularly like the dark, and I don't particularly like being cold. So I'm a big fan of the light and the warmth the sun brings. We wouldn't be the planet we are without the sun.
Yeah, Emily, I echo Jaws, and I like the brightness and the warmth of the sun, and I'm looking forward to the next solar eclipse.
That reminds me of something that my friends in heliophysics say, which is that the sun touches everything. With that, I want to thank you so much for taking the time to chat with me today about the sun, and I hope that you both have a great view of the eclipse wherever you might be, and good luck with the rest of your mission.
Thanks so much, Emily. Have a good one.
Station, this is Houston ACR. Thank you.
I mean, how cool is that? Can you imagine seeing the shadow of an eclipse on Earth from space? It would just have to be incredible. Now, folks, the crowd is growing here in Kerrville, Texas, as we inch closer to our moment to witness that Ring of Fire effect in person. Now, it's a good time to check in with James at our Eclipse desk. James, how are things looking on your end?
Hate to hear, yes, so we're still just a little bit away from the annularity here in Kerrville, Texas. Really cool to see the science going on in the International Space Station. Coincidentally, there's actually some really cool science going on just a little bit to the west of us in just a few moments in White Sands, New Mexico. And right now I'm actually joined by scientist Jamie Favors, who can walk us through exactly what we're about to see with this sounding rocket launch. Jamie, thanks so much for joining us.
Thank you so much, James.
Yeah, so is this your first annular eclipse?
It is, yeah, and first time launching rockets into an eclipse too, so.
Amazing, and we're about to have the first of 3 launches. I understand we're kind of timing these launches out to specific times here, right?
Yeah, so you're exactly right. So we'll have 3 launches during the eclipse, about 35 minutes before the peak. That'll be this first one, right in the middle of the peak, and then 35 minutes after the peak. Studying that upper atmosphere, the ionosphere, kind of see what are those impacts from the sun that really change, important features of the upper atmosphere that impact things like radio communications, satellite operations. Yeah.
And we just had a launch yesterday in Cape Canaveral, Florida, of our Psyche mission. That's going out into deep space, but these rockets, which just launched actually here,
Perfect.
this is just took off, so this is actually going to come back down afterwards.
That's right. So we're seeing first stage burnout here, about 6 seconds in. Blink out for a second, so the rocket's still moving along. There we see the rail, the pad that we just launched from. So as we're launching into space, we're going to start making measurements roughly about a minute into launch. So we're a few seconds in now. I bet we're getting pretty close to the second stage lighting off at this point to take us all the way into space. So roughly that 1 minute mark is where we start to do a lot of the science. The payload separates from the rocket. We have some deployables we'll release from that payload out at that point. We'll start moving that payload around in space so that it's starting to make good measurements. We have these booms or arms that come off of the payload, start making different measurements there of like magnetic structures, electric structures in the upper atmosphere, as well as temperature and density. One way to kind of think about this, what the shadow of the eclipse is doing in that upper atmosphere is it's creating these waves as all those temperature and density changes are occurring. So kind of think about it in the way of like a boat moving through the water.
Yeah.
We've all seen a boat move and you see the waves propagating out from it or moving away from the boat. That same thing is happening here with the eclipse and that shadow. So with those 3 rockets, we're launching one right before the boat moves through, one right in the middle of the boat coming by, and then one right after the boat moves through, or the eclipse shadow.
Sweet, and so we are just now a couple minutes away from actually getting annularity here in Kerrville, Texas. Our first view is actually going to be up in the Pacific Northwest, up in Eugene, Oregon. They are going to be experiencing this starting at around 9:17 local time. Jamie, thank you so much for joining us. Best of luck for the next 2 launches.
Yeah, thank you so much, James.
Back to you, Tahira.
Wow, I mean, if the day wasn't exciting enough, now we've got a rocket launch in the mix. It's
so exciting.
It's incredible. And I mean, what a NASA broadcast, right? And so thank you, James and Jamie. Now, Gina, we have a lot of great questions rolling in from our viewers online. How do you feel about taking a few?
Let's do it.
Okay, let's do it. So our first question is from Entertainment on Facebook, who asks, how often do eclipses happen?
Great question. Well, thank you for that. So there are actually eclipse seasons. And so we can get eclipses about 2 to 3 times a year. You might expect them to happen every time there's a new moon, but that's not the case because the orbit of the moon is tilted by about 5 degrees, which means sometimes the shadow is a little too high and it doesn't hit Earth, and sometimes a little too low. So we need those eclipse seasons as that sweet spot.
Okay, nice. And so I actually have a really great follow-up to that.
Okay.
Spectacular Science Podcast on YouTube asks, how do you predict solar eclipses then?
Okay, well, it's actually pretty straightforward how to calculate the eclipses because we have a good understanding of the moon's orbit. We have a good understanding of the Earth's orbit and how that whole system is connected. And so we kind of take the geometry and the inputs that we have, and we're able to pretty accurately predict those eclipses. And so these are things that we can look out decades in advance to understand when eclipses can occur.
Oh, cool. And so how often would an eclipse pass in the same city? Do you know?
Well, so for total solar eclipses, it's very unique for an eclipse to pass more than, it's about once every 375 years that a location can experience it.
Awesome.
Yeah.
So we have a user on X who asks, will the International Space Station photobomb the eclipse? That would look very cool.
Yeah, and so we just got to hear from the International Space Station, and the unique thing about our astronauts on board is that they have a totally different vantage point for studying the eclipses, and they get to actually view the shadow of the moon as it passes over the Earth. And there are experiments that we have on board the space station as well. And so, with NASA, we have all of these different eclipse experiments environments that are taking place, and we try to take advantage of every perspective that we have.
Awesome. So we have a final question from Dante. This is going to be a quick one.
Okay.
But Dante on Facebook, who wants to know, will the moon block solar wind along its path during this Ring of Fire eclipse?
Oh, I love that question. So the solar wind is actually a stream of charged particles that's constantly coming off of the sun, and it interacts with the Earth and other planets in our solar system. Now, the Earth's magnetic field actually blocks a majority of those particles from interacting with Earth. Some are able to get through and interact with our upper atmosphere, but for the sake of the eclipse, most of the particles will still kind of be able to be deflected around the Earth's magnetic field. There will be some that are able to interact with the moon, but it wouldn't have a huge impact on what we experience at Earth.
Fantastic. Thank you so much, Gina. And
You're
thank you to
welcome.
everybody sending in these questions online. We will get to some more of what you want to know by later on in the show. So keep sending those questions in using the hashtag AskNASA. Now let's check in with Joy and Michael to see what's new in Albuquerque. Joy, how's it going?
Thanks to her and Gina. So we're just under 30 minutes away from Annularity in Albuquerque, New Mexico. Michael, shall we put on our glasses to see what the sun and moon are doing?
Yeah, let's do it.
Okay.
Okay, so you're seeing a deep partial solar eclipse. More than half of the sun is blocked out, and so you just see a crescent of sunlight peeking out.
Wow, that is amazing. Annularity is just going to be stunning. I can't wait.
Oh, I can't wait either. This is terribly exciting. You can see a balloon inflating behind us. We have annularity coming. It is all coming together today.
I just can't believe that an annular eclipse is happening at the same time as the fiesta.
It really feels special, doesn't it?
And actually, earlier this week, I even got to fly in a hot air balloon, which is just amazing.
That's fantastic.
I met an amazing balloon pilot, Jonathan Wolf, who's been launching balloons in Albuquerque for decades. So let's take a look at our ride. So for complete newbies, how does a hot air balloon work?
It's a great question. It's physics, simply. We heat up the air inside the balloon, and that makes it less dense, and then that makes it float. Now, what that means, though, is we can only control up and down. The way we fly and the way we navigate is by choosing different layers of air to fly in.
And I've heard that there is a box, the Albuquerque box. Could you explain what that means?
Certainly. It's one of the reasons why Albuquerque is a famous place for ballooning. Sometimes what happens is at a higher elevation, the wind is going to the north, and at the surface, it's going to the south. That's what we call the Albuquerque box. Sometimes the box works out such that you can fly to the south and go up, fly to the north, and then come down and fly back south and land right where you took off, which is an extraordinary and wonderful accomplishment. It's super fun when you can do that.
So for someone who's never been in a balloon, what is it like?
It's unlike any other form of flying. In a balloon, you're actually outside, right? You're standing in a little basket, and there's no windows. You're just out there in the air, and it's just science, right? It's buoyancy, like I said, it's applied physics, but it feels like magic. It's a ballooner eclipse.
Oh yeah!
I love that. It's very calm. There's no movement, no wind. When you're moving with the wind, so you're at equilibrium. It feels very calm and peaceful. At the same time, it's really exciting and it's intense. So it's this wonderful combination of intensity and mellow, serene, tranquil, beauty, absorbing nature. You can never experience that in any other form of flight.
Wow, that brings back great memories. And if you can hear the wind behind us, they're actually inflating the balloon I rode it in just behind us, which is so cool.
So was that your first balloon ride?
It was my first balloon ride, yes.
Oh my goodness, how did it go? I remember taking one about 20 years ago and it was fantastic. What was your experience?
The most surprising thing is that when you're up there, you don't feel any wind against you because you're actually moving with the wind, so it feels completely calm.
Oh, that's fantastic. So would you do it again? I found it terribly relaxing.
100%, yes. So it was actually also not that chilly, and we were only a few hundred feet off the ground as well.
Wow, that's amazing, because it's been chilly here all morning.
So as we learned earlier, NASA's scientific balloons fly much higher. They actually reach a part of our upper atmosphere where our International Space Station lives and where some of our satellites fly as well. So it's really important we learn about this upper region and how it could affect our lives on Earth. And NASA and NOAA are two agencies in the US that work together to help study this. And I'm joined with two people who can tell us more. So we have Dr. Elsia Talat from NOAA and Dr. Kelly Corrick from NASA. Thank you both so much for joining us.
Very excited to be here.
Very excited to be here. Thank you so much.
So let's start off with the basics. Elsia, what are those changes we see in that upper region?
Well, part of what we call space weather, which is the variable conditions on the sun, the Earth, and near Earth space due to solar and geomagnetic activity and storms. And that can affect human activity and our technological infrastructure.
Wow, fascinating. So, Kelly, how does space weather actually affect our life here on Earth?
Well, Elsie had alluded to the fact that it challenges our technology. So our power grids are sensitive to those currents that can be induced by this, as well as our satellites could also be impacted by these flares or the space weather. And we get some beautiful things too. We get the aurora out of it.
Have you ever seen the aurora?
I have. Was absolutely beautiful. I laid on the ground for hours in the snow watching it.
So talking about space weather and the activity in our upper atmosphere, how do NOAA and NASA work together to better understand those phenomena?
Well,
Let's start with, yeah.
NOAA is a go-to resource for space weather information. It watches the sun and the Earth 24/7, and it's the nation's official source of forecast warnings and alerts for space weather to help decision makers prevent and mitigate the effects of space weather here on Earth. And in order to do this, we need information, and NOAA works with NASA to design, develop, and deploy space weather operational satellites to safeguard our society.
And what's NASA's role?
So NASA is a partner with NOAA, and we focus on the science and make sure that we're understanding our star and can do better and better predictions. So scientists use models and the data from all of these satellites in order to better understand space weather.
And what are some of the biggest mysteries around space weather? What don't we know about it?
Oh, there's so much. I mean, let's start at the sun, right? That's the focus today. Even how to predict flares long term, or those large coronal mass ejections, those billions of tons of material that come off. We don't quite know how to predict them for a long term yet.
Well, I'm so glad we have two agencies on the case. Thank you both, Elsa and Kelly. Thank you both for joining us. So, did you know that space weather is also affected by solar eclipses? One citizen science project does experiments during the annular solar eclipse and the total solar eclipse. So, let's learn more about that project.
When the moon blocks the sun during a solar eclipse, there is a noticeable impact on Earth's upper atmosphere, known as the ionosphere. These changes can affect radio communications, including amateur radio, also known as ham radio.
Ham radio is a way you can talk to people all around the world. You set up a radio and antenna. You talk into the radio sends a signal up to the antenna sends a signal up to the sky. It bounces off of the electrified layer of the sky back down to Earth, where you can talk to the person on the other side.
During the 2023 annular eclipse and the 2024 total eclipse, the Ham-Sci Citizen Science Project is inviting ham radio operators to transmit radio signals. The goal is to have people make as many radio contacts as they can with operators in different locations during these celestial events. By recording how strong their radio signals are and how far they go, ham radio operators and scientists can learn about how the ionosphere changes during solar eclipses.
Sometimes you can talk around the world, and sometimes you can't. And that's all based on what the ionosphere is doing, what the sun is doing. When it works and you are able to talk to these faraway places, I find that really magical.
To learn how you can participate, follow Do NASA Science on X and Facebook.
There are currently ham-sci experiments happening right now across the country, and there'll be more during the total solar eclipse on April 8th, 2024. If you want to learn how to participate, go to hamsci.org. So next, we're thrilled to be joined with the acting director of NASA's Heliophysics Division, Peg Luce. Peg, thank you so much for joining us.
Oh, it's such a pleasure.
So how are you feeling about the annular eclipse today?
Wow, it's happening, and we've been looking forward to this for so long. these are a rare celestial event that people can actually experience the effects of. So it's really exciting.
I'm so excited.
I am too.
So we've been chatting about the sun all morning, but can you tell us in detail what heliophysics is?
That is a good question. Many people ask. Heliophysics is actually a word that isn't yet in the dictionary, so we want to put it there. But helio is the sun. Physics, the science of matter and energy and how they interact. So we study the sun, how it works, how its energy flows out and affects all the planets, creates the solar system. And it's a very complex field and very exciting to study.
So we heard earlier that the sun touches everything. Can you describe a little bit about how the sun touches other NASA science disciplines?
Yes. So we like to say that heliophysics is really the science that interfaces and collaborates with all of the other areas of science that NASA studies. For instance, the sun is a star. And it's the only star that we can actually study up close. So for our astrophysics friends, we can learn in detail how our star looks, how it changes, how dynamic it is. So when they're using their tools like James Webb Space Telescope to study distant stars, they have up-close information from what we have learned. And then, of course, the sun's energy flows around all of the planets. It interacts with the Earth. Space weather affects the atmosphere of the Earth, and so it really is a collaborative and exciting field of study.
I love that the sun touches everything at NASA. So how does NASA touch everything we have here on Earth?
So I like to take this opportunity to remind people about NASA science. So most people, when they think of NASA, they think of astronauts and human spaceflight, which is, of course, so exciting. But NASA science is rewriting the textbooks all the time. We have so many discoveries and just so much. We have a Parker Solar Probe that is flying through the corona of the sun. We have the Voyagers that are outside the heliosphere. We have so much to learn that I could never even begin to talk about it, but I want to invite people to go to NASA at Home and check it out. You'll get just a little bit of more information about all that NASA science does.
It's an exciting time for NASA science.
It really is.
Yes.
Thank you so much, Peg.
Thank you.
So now let's head back to the Eclipse desk in Kerrville, Texas, where they're about to start tracking the start of the annular eclipse across the United States.
Thank you, Joy, Michael, and Peg. And Joy, you are absolutely right. Folks, we are moments away from the start of today's annular eclipse in Oregon. Now, I know I'm excited. This will be the first time I've ever witnessed one of these events, and I hope you are too.
It'll be my first annular eclipse as well. But Tahira, I was lucky enough to see the 2017 total solar eclipse, and that experience was amazing. So I think we're in for a treat today.
So this is going to be a totally new experience for you.
It will be, yeah.
And so, Gina, actually, you know what? Let's go ahead and see if we can pull up the telescope feed from our friends at Time and Date. Wow.
Look at that. San Diego.
Oh, San Diego. We've got a live view of San Diego, California right now. What a beautiful partial eclipse.
Yeah, I mean the sun, it's a crescent. Normally we refer to the moon as a crescent moon, but this time it's the sun.
And I mean, normally we see, you know, the sun in the sky, the moon in the sky. Occasionally they might be together, but to see them overlapping, it really reminds you that we're a part of this just entire system.
I know.
And so
interplaying together, right? And you can tell, I mean, from this view, you can really appreciate the fact that from our perspective, the moon and the sun seem to look like they're the same size, even though in reality they're not, right?
It's incredible. You know what? Right now, let's go ahead and check in with James at our Eclipse desk. James, what's the latest?
Yeah, hate to hear us. So we have officially kicked off annularity here in the United States. If we look at our Eclipse Explorer, you can see that the area of effect of that annular eclipse has now hit Eugene, Oregon. They should have a phenomenal view there. And just a reminder to all of our viewers who are in that region, the Pacific Northwest, be sure to use your eclipse glasses as you're looking at the sun and the moon above. You should have a beautiful sight at this moment. That's going to last for just a couple minutes, so really take advantage of that big moment. You just saw that view in San Diego. Even if you're outside of this area, you might still have a beautiful view of a partial eclipse. And if I zoom in onto our little area of annularity, you'll notice kind of a couple little bumps and things here, which you might initially think is because it's low resolution, maybe it's a little bit, low res here, but the inverse is actually true. We actually have an incredible amount of data feeding into our Eclipse Explorer to generate the images and the predictions that you're seeing on your screen. This tool takes into account two unique things. One is obviously the topography of Earth, so mountains, river valleys, all kinds of little divots and things as that shadow moves across the land. But also, and really interestingly, it takes into account the shape of the moon. When you think of the moon, you might just think it's perfectly circular, but there are so many little objects like mountains and craters and all kinds of things dotting the surface that are all being fed into this prediction that you're seeing here that will then show you exactly what the shadow is going to look like. You won't really be able to see this difference from the ground, but if you're up in space looking down at this, you'll actually be able to see that area kind of ripple almost as it's moving across the terrain. So definitely I encourage you to check out this tool. It's a really phenomenal one that's really just using so much data to feed into this. And again, even if you're outside of this area, I encourage you to use our tool to kind of predict what you're going to see. So if I scroll all the way over to the East Coast and I zoom all the way out here, you can just see just how large this area of partial eclipse is. This kind of outer circle that you see here is areas that might be having a partial eclipse. So if I click on, for example, Philadelphia, I know quite a few people watching there. It looks like it might be a little bit rainy, but if the sky clears up for you, you'll have a peak coverage for your partial eclipse at around 1:21 local time. So still plenty of time for you to get your glasses ready in order, get your pinhole projectors created. You had that instructions earlier in the broadcast, and really just take advantage of this incredible celestial moment. These don't really happen very often, so it's a really unique experience to be able to witness this live from here in Kerrville, Texas. Just a few moments, we'll actually be able to have that view from right here. I can hear the crowd already kind of buzzing. People have all their glasses ready to go, already kind of looking up and observing that partial eclipse. You just saw the coverage in San Diego. This is really sweeping across such a big area of the United States, and it's going to continue to move closer and closer and closer to us. You can see already since I've just started this conversation here, we've already moved away from Eugene, so they are no longer in annularity, and this is continuing to move into parts of Nevada. This will then continue to track further southeast to our friends out in Albuquerque at the Balloon Festival. They'll have a phenomenal view there, intermixed with the balloons and everything. It'll look awesome. And you're also seeing right now our live view of Kerrville, Texas. You can see we're already in pretty good coverage here with the partial eclipse. If I click on Kerrville on our interactive map, you can see that we're expecting our peak coverage of the annularity to begin at 11:50. And I'll remind you again, if you're using our interactive tool, these are all clickable too. So if you wanted to click onto those and to see exactly what time and exactly what it's going to look like, actually, this is a prediction of what it's going to look like in your neck of the woods. And so actually the path you're seeing this moon taking is the exact path it's going to look like the moon's taking in real life for you. So that little googly eye is showing that directionality. So for us, the moon has already entered in from kind of above the sun here. It's going to continue tracking down, eventually giving us that incredible ring of fire effect. I can't wait to see this live. This will be the first time for me ever seeing an annularity live. I'm super excited. So the hit is coming up again in Albuquerque, New Mexico. In just a little bit, they'll get a phenomenal view there. Keep tracking it. But for now, back to you, Tahira.
Incredible, James. And I mean, I think earlier you said buzzing. Like, Gina, it feels like the town is coming alive.
It is.
It's starting to get a little colder here.
I know, I'm kind of chilly.
And so,
I mean, looking around, you can just see people are kind of lounging back with their safety eclipse glasses and just taking it all in and getting excited for this.
And not only will Kerrville see today's annular eclipse, they're also positioned to see the total solar eclipse next year.
Yeah.
Right? Like, how awesome is that? And so, folks, let's take a look at how the city has been preparing in the lead up to these special events.
Kerrville is the eclipse capital of the state of Texas. It is known as being the capital of the Texas Hill Country. It's the epitome of Texas. Ranches, deer, beautiful streams like the Guadalupe here.
Kerrville is very welcoming.
It's a wonderful community.
Tight-knit, small.
It has about 25,000 people.
Kerrville is blessed to be in that special square. Not only are we going to witness the annular eclipse in 2023, we're also going to witness the total solar eclipse in 2024.
We're talking about crossroads, you know, we get it twice.
Two eclipses is coming right here, right where I stand. It's statistically extraordinary.
We get two
in less than 6 months.
Everybody's excited about it. City Council, county commissioners, everybody's working diligently to be able to provide safe opportunity for the influx of people.
This will be the biggest event in the history of the city, and that's why the city is preparing. We're preparing to make the event enjoyable for everybody who wants to see this tremendous natural phenomena.
I think that Kerrville has done an awesome job of preparing, way in advance.
It's getting that message out to people to make sure that they're taken care of personally, but then there's the science part of it, letting them know what is an eclipse.
And I'm just having a great time going out and talking to civic organizations and clubs and to talk about eclipses. So this will be my 4th and 5th solar eclipses.
I've seen total eclipse in Nebraska. I drove 1,200 miles for a little over 2 minutes, and it was well worth it.
And just couldn't believe the experience of the eclipse. I mean, it literally gives me goosebumps every time I talk about it. It's a visceral, emotional experience that is just, you have to experience it to understand.
I thought I knew what it would be like, but I gasped at the sheer wonder.
It's going to be you're going to hear that intake of air and awe.
It was the most beautiful natural thing I've ever seen. So to have an eclipse basically in my backyard is just, it's indescribable.
As you can see, the town is alive, preparing for these spectacular moments. Now, Gina, the sun not only impacts us here on Earth, right?
That's right, Tahira. So the sun impacts our entire solar system. And in fact, when we explore with NASA, that's something that we have to take into consideration.
So I'm glad you said exploring, because I actually just recently learned that the sun even impacts human exploration in the solar system, which I thought was really cool. So let's take a second and see how studying heliophysics is actually helping us prepare for sending humans to the moon and Mars under our Artemis program.
NASA has studied the sun and its influence throughout our solar system for decades. The Artemis program will provide a better understanding of solar activity through 2 new missions. Hermes is an instrument package that will monitor space weather from the moon and be placed on NASA's Gateway, an orbital outpost being built for lunar operations and eventually Mars exploration. The dual spacecraft Escapade mission will examine the effects of solar wind on the red planet's atmosphere. Heliophysicists at NASA are working to protect astronauts who will travel to the moon and to Mars by increasing our understanding of the space environment through which they must travel. With safety ever at the forefront, the agency is using spacecraft observations and simulations to better understand space weather. That's a look at your Artemis Moon Minute.
Folks, I've learned that it is almost time for Annularity to make its move into Albuquerque, New Mexico. We've got Joy standing by at our other desk, who is going to tell us about an upcoming NASA mission and show us live views from this solar eclipse. Joy, Michael, on a scale of 1 to 10, how excited are you right now?
I think I'm about a 20 right now. What about you, Michael?
Oh, I am so excited. You can see the light changing. It's getting a little bit chilly. I am so excited.
I cannot wait.
Yeah.
So now we're joined with NASA scientist Dr. Nikki Weil, who's going to tell us about a new sun mission. Firstly, Nikki, how are you feeling today?
It is so amazing to be here. I'm so excited to be able to be a part of this festival and witness the annular eclipse.
So Nikki, what is the PUNCH mission and what does it stand for?
So PUNCH is a NASA small explorer. It stands for Polarimeter to Unify the Corona and Heliosphere. So the corona is the outermost atmosphere of the sun. It's the part of the sun that you get to see during a total solar eclipse when the moon totally blocks out the main body of the sun. And then the heliosphere is the bubble carved out by the sun as that corona turns into a solar wind and fills our solar system.
So I know that PUNCH has a big outreach effort as well, especially looking at humanity's interaction with the sun and observing the sun. Can you tell us a little bit more about that?
Yeah, humanity has been studying the sun and the moon and those different cycles for millennia. And one place where there's a lot of evidence of that studying of the sun is over in Chaco Canyon here in New Mexico. And actually our Punch Outreach team, some of our Punch Outreach team is over there in Chaco right now, where there's just so much evidence of ancient and modern sun watching. The ancient sun watching there evidence is on the rock of the sun, there's this petroglyph of what we think might be the 1097 total solar eclipse that actually went right over Chaco Canyon on a path similar to the annular eclipse today. And then of course, the modern sun watching is what we're all doing here today, and of course our Native American partners on the Punch Outreach effort that still honor some of their traditional sun watching efforts, and then of course our NASA missions like Punch and Parker Solar Probe.
That's amazing. And you mentioned Punch shows and studies the sun's atmosphere, the corona. Why do we need to study the sun's atmosphere?
The corona is amazing because it is hundreds of times hotter than the photosphere below it, the surface of the sun, the part that we should never look directly at. So that's amazing. That's like if you walked away from a fireplace and it got hundreds of times hotter. Now, we know it has to do with the magnetic fields rooted down in the sun, but we don't know exactly how that energy gets into the corona. So that's one of the things we're really interested in studying.
Right, so we're looking at a live shot on camera of this eclipse. We're getting really close to annularity. So what are you looking forward to as a scientist when you think about eclipses and especially with the new mission coming up?
Punch is going to be so amazing because it's going to take images of the corona and that plasma as it fills the solar system in regular white light, like we could see it with our eye if our eye were sensitive enough and if the moon always blocked out the main body of the sun. But it doesn't, and that's why we need NASA missions like Punch to do that for us.
Fantastic. I can't wait for the mission to launch.
Me neither. I'm super excited about it.
So we're like we're moments away, minutes away from the annular eclipse here. Nikki, thank you so much for joining us. I hope you enjoy the annular eclipse.
Yeah, thank you so much. This has been great.
And I hope you keep safe from the wind. The wind is kind of picked up right now. So yes, so the skies are clear, the wind is picked up, but we have a clear view of the annular eclipse. So remember, the annular eclipse is moments away from Albuquerque and the sun is never completely covered. So during the eclipse, you have to keep your eclipse glasses on the entire time. You can also use other indirect viewing methods too, like a pinhole projector if you don't have eclipse glasses. So Michael, do you have your glasses ready?
I have mine ready.
Great. So now let's go to a full screen view of the telescope here in Albuquerque. Wow.
Wow.
We are minutes away and you can see that the ring of fire is almost here.
Yeah, the sun is just egressing over into the moon, or the moon's egressing onto the sun. We're getting closer and closer. The light here on the ground is visibly different, and looking up at the sky, where we see a thumbnail moon. It is our thumbnail sun. It is gorgeous.
Wow. The ring of fire, the almost ring of fire, it looks so sharp and clear with our beautiful skies today.
Yeah, it really is almost that Johnny Cash moment. We're getting close to the ring of fire. It is really beautiful to see happening in real time as well. This is one of those events where I can sit and watch and see how the moon is progressing and see that changing.
I can't believe that the moon, we can actually see the moon moving in front of the sun right now. You can you can literally see it. It's just incredible.
So as we approach annularity, you might be able to see Bailey's beads. These are bright points of light of the sunlight coming through the valleys on the moon itself, right before the annularity begins.
You can even hear the crowds in the background. You can just feel the atmosphere building up.
Yeah, it is palpable. Everybody is super excited here. I know I am just thrilled. We are just in the final countdown. You can hear some people starting to cheer and starting to get all pumped up themselves.
Wow, the ring of fire is almost here. I'm just going to take my glasses off briefly and you can see the crowd, everyone is just staring safely at the sun right now. It's just amazing that we're all united looking at this amazing celestial event.
And make sure you take a look at the shadows around you. You're going to see these crescent shadows everywhere as different objects create natural pinhole projectors. And so make sure that you do have a moment to take a look at the world around you, because there's a beautiful rings. So let's take a minute and just be quiet and enjoy the view. It is a gorgeous sight to behold.
Everyone is cheering. This is so amazing. Wow.
Yeah.
This is amazing. You can hear people screaming in the background.
People are so excited. And take off your Eclipse glasses safely, of course, and make sure you look at the shadows around you, look at how the environment has changed, just make note of this entire event.
Wow, this is so amazing. This really puts our planet in perspective with the whole solar system, you know?
It's truly spectacular. It's one of those natural phenomenon that I just feel so lucky to be here at this place at this time to be able to observe it.
Wow, I'm just looking at a tiny pinhole below, and I see a little ring, like a little spotlight. This is so cool.
You can see ringlets dotting everywhere around here. See people taking pictures of the ground.
How are you feeling, Michael?
Oh, this is spectacular. You know, we've been preparing for this event for so long. To actually be in this moment and to be experiencing it live is just tremendous. Joy, how are you feeling?
I'm just in awe. You know, I can feel the temperature drop, and this ring of fire feels so long. It's just about 4 minutes long, and it feels just incredible that we are seeing moon right in front of the sun right now.
So that moon's shadow is traversing across the ground at a few thousand miles an hour, almost Mach 3. So even though it seems like it's lingering, it's actually making really good progress, and pretty soon our colleagues in Kerrville will be seeing annularity too.
Wow, and the crowds, everyone is still staring, looking at the annular eclipse. I love that everyone is here together, enjoying this together. Wow.
Yeah, you can almost hear a little bit of an awe and reverence among the crowd. Initially, there was a bit of cheering, and then everything got a little bit quieter as people took in the sight. I think that, you know, as people experience this event, it strikes both, you know, personal but also communal, and it's a really beautiful, beautiful event to see.
I would say we have about thousands of people in the fiesta today, and hundreds on the museum grounds. Everyone is just excited about this eclipse, and it's just so lovely to see.
I think also what I really love to do is to look at the crowd and see everybody looking up at the sky with their glasses on in the same place. It's just, it's fun to do a little bit of people watching as well.
Yes. Wow, this is a perfect ring of fire. It's just so crisp.
Yeah, it's fantastic. I'm so excited for the science that is going to be coming out of this too. Of course, I always come back to the science, and this opportunity to have the moon covered to this extent is going to provide us really amazing data about how the sun and moon and Earth how they interact with each other.
Oh my goodness. We have about 30 seconds left of annularity here. I just want to absorb this moment.
It's so fast and so slow.
Definitely. Wow, what a sight.
Sometimes you just have to take a moment to take it in.
Yes. Oh my goodness. Well, we have a few more seconds left of annularity in Albuquerque.
Yeah, we're closing down on the last little bit. See if you can see a Bailey's bead possibly popping up right as that edge of the moon it aligns with the edge of the sun. Just seconds left. Really such a gorgeous sight.
It really is. Oh, that is going to be a moment to remember.
Absolutely.
So Kerrville is going to be experiencing this very, very soon. So let's head back to them in Kerrville, Texas to see what they're up to.
Oh, I mean, Joy and Michael, like, I got goosebumps watching you experience annularity, and Gina, like, that is about to be us soon.
It's true. I mean, so Tahira, we're about 550 miles away from them, and we will have annularity in about 10 minutes because, as Michael said, the moon's shadow is traveling more than 1,000 miles an hour. Everyone's so excited.
Yeah, as you can see, the crowd is just getting excited for today's opportunity. And folks, it's starting to get dimmer here. Like, it is going to be amazing.
Yeah.
So, Gina, other than sheer beauty, why do we observe eclipses at NASA?
Well, NASA can learn a ton of different science from the eclipses. So let's talk about exoplanets for a second, because when we study exoplanets, we are actually using eclipses. The planet itself is passing in front of its host star, and so we can learn about the exoplanets. There are eclipses on other planets in our solar system that we can study, but here on Earth, the science that we're able to do will inform us about the upper atmosphere and how it responds to the sun. So really understanding kind of that sun-Earth connection. We can do lunar science as well, and of course, solar science, learning more about the sun.
So eclipses are touching Earth science, planetary science, sun science. That's
everything.
Incredible.
Across
and
the
NASA's
spectrum.
studying it all.
Yes, exactly. We take advantage of that, for sure.
Absolutely. I mean, spectacular sight, spectacular science.
Yeah.
So, folks, we have James standing by at our Eclipse desk with a telescope operator who's going to show us the next city experiencing annularity. James, how are things looking?
Yeah, hey Tahir, I just had a quick look outside. It is really surreal here. It's kind of hard to process exactly what we're seeing because it's daytime, but it feels like it's not. It's starting to get already very close to annularity. You can hear a lot of screams behind me now. Right now, we're actually getting the annularity in Roswell, New Mexico. They should have a phenomenal view outside right now. And I'm actually joined by a telescope operator who's been providing a phenomenal view for us all morning with her telescope. This is Kat Troche. Thank you so much for joining us today.
Thank you so much for having me. This is so exciting.
Yeah, it's really mind-blowing seeing it. And so you have quite the setup. Could you walk us through exactly what you have outside for us?
Sure. I have a Celestron 6 SE. It's a Schmidt-Cassegrain telescope with a solar filter on the front and a DSLR camera that's streaming to YouTube.
And so a Schmidt-Cassegrain telescope is a bit of a unique telescope. Usually you think of kind of like a long cylindrical thing, but this concentrates the image in a different way, right?
Right. So it's a little bit more compact. It's definitely designed for astrophotography in mind. And how it works is there is a glass corrector plate in the front. It's clear glass. And the light from anything that you're looking at, whether it's planets or in this case today the sun, will travel through the corrector plate to the primary mirror that's at the back of the telescope. Then that will bounce back into the secondary mirror that is attached to the corrector plate on the front, and then it'll go through again back at into the diagonal that's attached to the DSLR camera or an eyepiece if you're looking at it.
So a pretty complex process, and also you have to have special protection for the telescope itself because you're used to looking at pretty dim objects. What do you have set up for that?
So I have a white light solar filter, and it is incredibly important. Just like protecting your eyes, you need to have solar equipment for your telescope or your camera if you're photographing the sun.
Yeah, and so also this is obviously moving really quickly across our sky. You just heard from Michael that this is really quite a quick event here. So how do you keep it in the field of view of the camera?
Well, thankfully, the remote control that's part of the telescope actually has a city database set up, so I can program it for city and state, and Kerrville was actually listed.
Look at that. Very awesome. And yes, so you can see it's already moving very quickly towards us. This is where annularity is going to be currently taking place. You can see we're next in line here, coming up in just a little bit. So very excited to continue tracking this across our skies. Thank you so much for providing this awesome view for us all morning. You can really see it's really getting close now. It's got this beautiful crescent to it. Usually we're used to a crescent moon. We've got a crescent sun today. I mean, really awesome. And in just a few moments, we're going to have the Ring of Fire of Annularity. Very excited to have that. Thank you so much for joining us, Kat.
Thank you.
And back to you, Tahira.
Thanks, James and Kat. Now, we have about 6-ish minutes, 6:30, until Annularity makes its way here to Kerrville, Texas. As you can hear, the anticipation is high.
They're so excited.
And so, Gina, as we count down to the big moment, let's take a few social questions.
Let's do it.
Okay, so we have something to see here on X, who asks, am I seeing a couple of sunspots on the telescope feed?
Yes, so you are seeing some sunspots. As I look at the live feed, maybe not so much right now because the moon is blocking most of the sun, but when the moon wasn't covering as much of the sun, you could see some darker spots, some black spots here and there, and those in fact are sunspots, which are areas of really intense magnetic fields, and the surface of the sun is actually cooler, which is why they appear darker than the rest of the bright sun that we see. Now, we heard a little bit about space weather and some of that solar activity that's coming towards Earth during, some of the sun's activity, and basically these sunspots are where that activity can come from. And right now, the sun is in the part of its solar cycle where more of those sunspots start to appear. So the sun goes through an 11-year cycle, where it becomes active and then where it becomes less active. And right now we're inching towards what we call that solar maximum. And so more and more of those sunspots appear, and that's what we're seeing today.
That is incredible. And I mean, again, talk about activity. Gina, this crowd right now, like, folks, if you could see it, I don't know if you exactly.
There you go.
We have folks looking up already with the Eclipse glasses on. You see the live telescope feed in your on the screen right now. We are moments away. What I think is super cool, we've even got some folks out here with their own telescopes and cameras to really capture this spectacular event.
Yeah.
And so, again, it looks like we've got about 4 minutes. The crowd is growing, and I'm interested to see how everything kind of calms down too. So we'll see. Gina, I have another question. This is from Baron on YouTube, who asks, does a solar eclipse have a material impact on the atmosphere?
Oh, I love this question, because with the eclipse, we really are trying to understand the sun-Earth connection. And so you can almost think of the eclipse as a controlled experiment. Basically, the fact that we often, experience changes in our atmosphere during the nighttime, but the eclipse is almost able to turn off and on the sun. So
even right now, we were blasted with the sun earlier, and now it's just chilly. Like it's darker.
Yeah. And so it's the upper atmosphere that we're really interested in understanding, and the energy and the radiation from the sun creates what we call the ionosphere, this upper part of the atmosphere that's filled with charged particles. And so when the sun's radiation is not hitting the atmosphere, that ionosphere, it changes in its density, its temperature, and we're really trying to understand those changes, and the eclipse gives us that opportunity to really turn the sun on and off, which we can't do
in
any
a little
other
experiment
circumstance.
that honestly all of us also get to be a part of.
Right?
So that's really cool.
It is.
Thanks, Gina. So our next question is from Hunter on YouTube, who asks, does the solar eclipse affect the moon when it happens at night?
Okay, great question, Hunter. So today, as we're experiencing a solar eclipse, that means that the moon is between the sun and the Earth. Now, the lunar eclipse that can take place is when the moon is actually on the other side of the Earth. And so today we're experiencing that solar eclipse, and we see that the moon is very dark.
And it looks like, too, we're getting a live feed.
Looking at that feed.
Oh, of another annularity taking place right now. Odessa, Texas. Wow.
Oh, there we go.
It's cool to see this comparison right now. What is that? What's on the side of the screen?
We might have some solar activity.
Is that a Bailey's bead?
Yep.
Or solar activity? Wow.
Wow. That's
incredible. It is leaving Odessa right now and heading
It's coming
towards
our way.
us,
You
Gina.
can
Oh my
see
goodness.
in the other live feed that we just have that teeny tiny sliver of the sun left peeking out.
Wow. We've got about 2 minutes here, folks. As you can hear, the crowd is chanting and counting down until our moment right now. Oh, that is beautiful.
It's coming in so quickly, too.
And you can
And I'm going to
really
grab those
see
glasses
it.
so that I have them.
Okay, wow. So before we hit our moment and peak in annularity, folks, it's a good time to give a reminder that it is never safe to look directly at the eclipse without proper eye protection when watching even a partial or annular solar eclipse directly with your eyes. You must look through safe solar viewing glasses or a handheld viewer at all times. Do not look at the sun through a camera lens, telescope, binoculars, or any other optical device while wearing eclipse glasses. Wait, 1 more minute, folks. If you don't have eclipse glasses, you can use an indirect viewing method like a pinhole projector, which has a small opening and will project the image of the sun onto a nearby surface. You just heard it. We are under a minute away from the annular eclipse making its way across our area into Kerrville, Texas.
It feels like it's gotten here so quickly. We've been counting down.
I know.
And now we're less than
It
1
is
minute.
beautiful. And
Yeah.
so, again, you're witnessing firsthand the moon passing between our star and the Earth. And we're taking this full screen right now. Gina, let's take this opportunity and get a closer look.
All right.
Oh my gosh,
And looking
this is
around,
the
I mean,
first
everything is so
time.
dim. Oh, wow.
Oh my God. Wow, you know, like, why am I emotional right now?
Oh,
This
there
is-
we go.
Oh my God, this is.
I mean, it doesn't look real.
I didn't think I would cry. Like, what the heck is going on? Wow. This is.
Wow. It looks great.
I mean,
you can just see. It looks like a perfect circle of the sun
perfect
peeking out. It really is that ring of fire that we have here.
Wow. Gina, I thought I'd have goosebumps, but I'm like literally shaking.
मध्य केनिया की सागाना नदी ये
I
देश
know,
की
I
सबसे
agree.
लंबी नदी की मुख्य सहायक
So, I mean,
धारा
and I'm
है
just
लोग
first
यहाँ
annular
घूमने फिरने
eclipse.
आते
I mean,
हैं
was it
और
what
इससे
you
बिजली
expected?
उत्पादन में भी मदद मिल रही है
to hear. I mean, we've
जैसे कि
seen all of the
पर्यटकों के लिए बने
photos
इस
from
कैंप के
previous
पास
annular
करीब
eclipses,
10 साल
but
से
just as I
अपनी
look again,
पन
I
बिजली
mean,
टरबाइन है पानी के पहिए
it's
घुमाने के
incredible
लिए
how
नदी
the
का
moon
पानी
and the sun are
यहाँ
able to line
मोड़
up
कर
like
लाया
this.
जाता है
जब टरबाइन घूमती है और पानी ज्यादा होता है तो इससे 15 एम्पियर्स बिजली पैदा होती है पानी कम होने पर 3 एम्पियर्स उत्पादन होता है ये बिजली इन्वर्टर से गुजरती है और इन्वर्टर बैटरी को चार्ज करता है
So a little fun fact about our moon that's pretty incredible. It's 400 times smaller than the sun, but it's also 400 times closer to the Earth.
No
and
way,
that
400 and
400 is the
400?
magic number here. Yeah, the fact that 400 and 400, that means in the sky, the moon and the sun appear to be the same size. And that is unique to us on Earth. No other planet in our solar system has that ratio that makes it so special.
You're saying that if we viewed an eclipse on another planet, it wouldn't look like this?
It wouldn't. I mean, I'm sure it would be great to see, but it would not look as spectacular as this.
Wow. Okay, I'm gonna turn behind me really fast.
Yeah, looking around. And you can just see everything. The shadows are a little bit different. It's dim. You get this hazy feeling, but the sky is still blue. That's what's strange about it.
Oh, it's so sweet. We've got parents like holding little eclipse glasses on their kids to look up. This is just, it's really amazing how just like, I don't know, a natural phenomenon can really make the world pause for a second.
That's great.
Wow.
You heard the cheering, and now it's
I know,
quiet
now
again
it's
as people are
quiet.
just looking.
And so for us, this is going to last about 4 minutes until it crosses, right?
That's right.
And why is that? Is that the same in every city or?
Yeah, so there's actually the length of the maximum eclipse can change based on several factors. I mean, each eclipse is unique. And so One thing has to do with where in the moon's orbit the moon is, because the moon's orbit isn't circular, so it will go faster and slower at different parts, and that will make the shadow travel at different speeds. Also, where the shadow is landing on Earth will have an impact, because if you're at the equator, you're going to be rotating much faster than if you were at the poles, and so for that fact, it changes the length of that maximum eclipse too. And that's true not just for annular eclipses, but for the partial eclipses, for the totality, for total solar eclipses as well. And I imagine, you know, our folks at home getting some of those partial eclipses are also having a great experience too.
Wow. I don't know what I expected, but it wasn't this. Like, this is incredible. And so, Gina, I'm sure, I mean, you're in heliophysics, sun science. I'm sure some of your teams are studying today's eclipse. Like,
oh yeah,
what?
Absolutely.
So, what kind of science can only happen right now, you know?
Right. We've heard about the sounding rockets that are experimenting.
Oh,
you
that's
know,
right.
today,
We saw one, yeah.
studying the upper atmosphere. And so we're really interested in knowing, like right now in our location, as that radiation from the sun's being blocked, how does the upper atmosphere change? And so, in addition to that, I mean, we really want to understand how those sunspots, what's going on when they're covered versus when they are not covered. We can tell the difference in that radiation that's coming from the sun. And so there's so much science that we can do.
And this is just, folks, view is just so incredible. Before we fully pass through this transit, let's check in with James at our Eclipse desk. James, I know you are seeing this. What do you think?
It's truly a surreal moment. It feels like almost nighttime. It's been really breezy, chilly.
That was so
the shadows
awesome.
are all like little rings as well. It's just a beautiful sight. Kind of hard to put into words the exact feeling. I mean, we've been preparing for this for a while. We've, you know, been tracking this all morning with our Eclipse Explorer, but actually to see it in person and to take it in, it's a really incredible moment, and this only lasted about 4 minutes. You can see on our Eclipse Explorer, this is already passing off of Kerrville, heading further southeast to parts of the Texas coast on the Gulf. And the morning is far from over here. For a lot of folks in Central America and South America, their morning is just starting off here. The partial eclipse is affecting still a large part of the region. You can see this whole area that's highlighted here in the larger ellipse here. That's all being affected still by that partial eclipse. And you can see on our track that this is going to continue moving further southeast all the way into parts of South America before the morning's over. It's been just incredible tracking this. And actually, Kerrville, we're in the path of the total solar eclipse for next year. So if I turn on the path for next year, you can see X marks the spot here in Kerrville. We're going to be coming right back here to witness this incredible cosmic event once again, getting that incredible view. Just really, again, very hard to put into words just how amazing this is. Just a stunning experience, and it's been an honor to be here with you this morning, tracking this event as it's moved across. We started the morning in Eugene, Oregon. Now it has arrived and already passed us in Kerrville. I'll continue to track it for a little bit longer here, but for now, back to you, Tahira.
Thank you, James. And folks, this is just the beginning. Today's event kickstarts NASA's Heliophysics Big Year, which is a year where we're encouraging people to do as many sun-related activities as possible in the lead up to next year's total solar eclipse. Now, Joy and Michael in Albuquerque are going to share some of the ways you can play a part. Joy, what can we look forward to?
Now that the annular eclipse is here, the fun has just begun. So today is the official launch of NASA's Heliophysics Big Year. This is a year-long celebration of solar science, and it's modeled after the Big Year concept from citizen scientists in the bird-watching community. So they're challenged to see as many birds as they can, but in the Heliophysics Big Year, we're challenging you to do as many sun science-related activities as possible. And so one way to participate is through NASA's citizen science projects. Here are a few sun-related ones you could join.
Did you know that you can participate in solar eclipse science with NASA? NASA's citizen science projects are collaborations between scientists and members of the public, no matter your citizenship. Several volunteer science projects are gearing up for the 2024 total solar eclipse that you can join. Total solar eclipses don't just look cool, they provide a rare chance to see the sun's faint outer atmosphere. Using telescopes and cameras that are safe for viewing the sun, volunteer scientists across North America will capture images of the total solar eclipse. Scientists will study these images in detail, tracking how plumes of solar material move through the sun's atmosphere. But be careful, without proper tools and techniques, you can damage your eyes and your camera. Did you know you can listen to an eclipse too? Amateur or ham radio operators will send radio messages to one another during the eclipse to see how changes in the upper atmosphere distort radio signals. As the moon blocks one portion of the sun, it can make other portions easier to see. Working with local scientists at an observatory in Southern California, participants will observe magnetic hotspots on the sun as the moon passes over them, revealing details they normally can't detect. Want to learn more? Follow Do NASA Science on X and Facebook to see how you can get involved in NASA citizen science.
So as you can see in the telescope view, the moon is now moving away from the sun, which is really, really amazing that we're still seeing this partial eclipse.
Absolutely, and I think I can see a sunspot in there too, and I think on one of the earlier shots, I could see a prominence. So we're seeing NASA's sun science happening in real time.
So we're getting some amazing questions online. Shall we ask some more?
Yeah, let's get into it.
Answer some more. Okay, so we have a question from Peter Chang on X, and they ask, can filtered telescopes see flares on the sun during totality?
Oh, that's a really good question. The answer is yes. It depends on what filter, though. So if you use just a white light filter, then you have to have an exceptionally large flare in order to be able to see it. If you use a filter like an H-alpha filter that specifically selects one color of red light, then you're going to be able to see flares a little bit more frequently, even even during totality as the corona adjusts to that flare as it erupts.
Okay, so we have time for one more question. Yuri on X asks, if a solar system had more than one star, would they have more solar eclipses? Would they all look like the same eclipses that we have here on Earth?
Ooh, that is getting a little sci-fi, but that's okay. So if we had more than one sun, you'd have to have a moon to block both suns, or maybe two moons to block both suns. So you'd have to have a very complex geometry to get everything lined up perfectly so you could get solar eclipses with two suns and two moons, and oh, it would get very complicated.
Thank you so much, Michael.
You're welcome.
Okay, so now we're joined with NASA's heliophysics lead, Denise Hill, who's going to tell us more about how you can participate in the Heliophysics Big Year. Hi, Denise. How are you today?
Great. Did you see that? That was my first annular eclipse, and we got a prominence. I am so stoked. That was the dopest thing ever. Okay, okay. Heliophysics Big Year. So, as you've heard before, the sun touches everything. And the Heliophysics Big Year is a celebration, a global celebration of sun and sun science and what we have going on. But it's also, I think I heard you say it, Michael, it's about the community and being communal and just the unity of hearing everybody cheer. The sun touches us all in so many different ways. And so the Heliophysics Big Year is going to help us kind of discover all the ways the sun touches us scientifically, but in other ways as well.
And why is it a big year for the sun?
So you saw what just happened, right? Oh, well, that's nothing. Coming up in April 8th, we have the total solar eclipse, and then Parker Solar Probe's closest approach, which will end out the Heliophysics Big Year, but it's the mission that has literally touched the sun, and it's going to be making its closest approach. And then from there, every single month during the Heliophysics Big Year, and it's a big year because it's more than 12 months, but during that time, we have themes for on different ways people can explore the sun and how it touches them. So we have themes like fashion. We're going to be delving into physical and mental and emotional health. The sun touches us in so many ways besides. And then we have missions. In just a couple weeks, we have our AWE mission that is launching, and it's going to be the first space weather station on ISS. And we are so excited. You have no idea.
Wow, there's so many new NASA events and opportunities coming up. Is there any other like science events that maybe people could get involved with themselves?
Yeah, for sure. So we've talked about citizen science a bunch, and that is one of the ways for sure for people to get involved and to do NASA science with real scientists. And then there's also, like, you are a scientist. Every single one of us is a scientist. And we're going to share ways that you can explore the sun, do your own little scientific investigations yourself. And so, yeah, the science is going to be front and center. There's also going to be some other things as well.
That's great. So what are you most excited about in this upcoming big year?
For me, it's the unity, right? Like the sun touches, it doesn't matter what race you are, what ethnicity, what culture, religion, whether you live in a rural community, urban community, it doesn't matter. The sun touches us all. And we like to call it our extraordinarily ordinary sun, because our sun is supposed to just be ordinary. But it is responsible and touches every living thing on Earth. And no other star that we know of has that level of responsibility. So that gives me hope that you can be ordinary and have an extraordinary impact.
That's amazing.
Well, I think our sun's pretty extraordinary by itself, so I don't know.
Thank you so much for joining us, Denise.
Thanks for having me.
So if you want to learn more about the Heliophysics Big Year, you can visit go.nasa.gov/heliobigyear. Michael, are you excited for the Heliophysics Big Year?
I am so excited because I get to be a rock star for an entire year, and then I go back to being a normal scientist again. No, it's going to be fantastic for science, for outreach, for everything. I am so excited for this.
Well, the Heliophysics Big Year has so many opportunities for folks around the world to get involved with NASA science, especially during the 2024 total solar eclipse. And one group of citizen scientists will be using their sensors to make observations. They'll gather sound recordings and help with data analysis to understand how wildlife will be impacted by solar eclipses. And you can help them too, no matter your citizenship. So now let's learn more.
During a total solar eclipse, it is almost like day becomes night very quickly.
So knowing that there's going to be a change in that light and life-giving energy means that we can predict when animals are going to have a rapid shift in their behavior,
which results in changes in the acoustic environment or the soundscape.
So the Eclipse Soundscapes project is a project to determine how eclipses affect life here on Earth.
And there's a lot more to observation than just what you see. It's also important to think about what you hear.
We're measuring how the rapid onset of darkness during an eclipse affects wildlife by measuring the changes in sounds that they make.
The general public is best suited for this type of project because the general public is everywhere.
And that's really the power of the participatory science component of this project. It enables recordings and observations of soundscapes across the diversity of ecosystems covered by the path of totality. We might think of some ecosystems having a greater influence of human activities on the soundscape, whereas in other ecosystems, say a remote part of a national park, we might have a lower influence of human activities and greater influence from the sounds of life and Earth.
The only way to properly preserve a species is to understand it. The only way to understand it is through scientific study on their behavior, their patterns, and their habitat requirements. One of the things we'll be doing during the total solar eclipse is setting up these recording stations. So these are our acoustic monitoring stations. And what we're doing is listening for calls of the different bat species with the hopes of maybe picking up some of those endangered species like the northern long-eared bat. We're hoping the results of this study will inform us about the health of our bat populations on Hot Springs National Park and help improve future conservation efforts.
The Eclipse Soundscapes project is an inclusive and accessible project that is inviting the general public to get involved in NASA science alongside scientists and subject matter experts.
Wherever you take your observations, you might be giving us information that has never been recorded before. And that is really useful and interesting to a scientist.
Wow, that sounds
Urban
like
fighting is going to be incredibly dangerous for your troops,
as well as. If you want to learn more about Eclipse Soundscapes or any of other NASA's other citizen science opportunities, go to go.nasa.gov/heliobigyear. Well, thank you to everyone joining us online and here in Albuquerque, New Mexico. It's been an unforgettable day, hasn't it, Michael?
Oh, it certainly has. I will never forget this day. It has been just a day full of activity and memories that will last a lifetime.
So although the annular eclipse is over in Albuquerque, we still have one more day left at the Balloon Fiesta and 1 year to participate in as many sun signs related activities as possible in the heliophysics big year. So now let's head back to Kerrville, Texas, where Tahira and Gina will chat about the upcoming total solar eclipse. Thank you so much for joining us, everyone.
Thanks, everyone.
And thank you, Joy and Michael. I mean, it sounds like we have so much to look forward to over this next year. And folks, even though peak annularity just passed in Kerrville, Texas, we are still getting an incredible view on this live telescope feed. You can see the moon is now passing over the sun and honestly on its way to make another city's day. Now, it is a good point to remind folks that X marks the spot here in Kerrville, Texas, where the 2024 total solar eclipse will pass in just 6 months. This very lucky city is in the path of totality and will be one of the places to witness the moon completely blocking out the face of the sun and darkening the sky as if it were dawn or dusk. Now, Gina and I are here with NASA Chief Scientist, Dr. Kate Calvin, to learn more about what we can expect for next year. Kate, thank you so much for being here with us.
Thanks for having me.
Have you. And so, Kate, can you start off and just give us an idea of what science we can expect only for a total solar eclipse?
So one of the things that scientists are really interested in studying is called the corona. It's a part of the sun's atmosphere. It's the source of heat and particles that come towards Earth. But normally it's too bright, and so you can't really observe it directly. Scientists use instruments called chronographs to block some of that light, but it's still hard to see parts of the corona.
It's not the same as a total eclipse?
Yeah, the total eclipse gives the best environment for studying the corona.
Right, but we were so lucky to just see that prominence coming off of the sun.
And what is the prominence?
And so that's actually some of that solar particles, some of the particles coming off of the sun, the ejecta, and we can kind of see it hanging there, which either turns into an eruption, some of that activity that we can observe, or it can kind of just quiet down as well. Yeah. So, Kate, can you tell us, how can the public get involved with the total solar eclipse?
Oh, that's a good question.
Yeah, so we have a number of citizen science projects. These are projects where people anywhere around the world can help contribute to our science. You don't have to be in the path of totality to contribute. We have projects for everyone. And they're different projects. some of them you need cameras or telescopes or equipment. Others you can use just with your cell phone. So we have one project that's called On the Globe Observer app. It's help understand the effect of eclipses on Earth's weather, and you can do that just with your phone.
Do you need a science background, or?
Anyone can contribute. We walk you through what you need to do, and sometimes it's as simple as taking a picture or recording a sound. And so you can all contribute to our science.
So anybody can get involved?
Anyone can get involved.
Perfect. And then can you tell us a little more how the eclipse science that we're doing will help to inform kind of the broader science at NASA?
Yeah, and so like I said, we're trying to study the corona, the source of heat and particles towards Earth. They affect Earth. They can disrupt electronics. They can lead to northern lights. So we're really interested in Earth and understanding the effects on Earth. But there's also the sun affects other planets and bodies in the solar system, like the moon and Mars. And so when we think about exploring the solar system, we want to understand the sun and its role in it.
Wow, that's incredible. I mean, we have so much to look forward to next year. I want to know real quick, what's your peak excitement for next year's total solar eclipse? We'll start with you, and then Kate would love to hear your thoughts.
Sure. So I'm really excited to compare what we saw today, that annular eclipse. How does it compare to that total solar eclipse? I got to see a total in 2017, but every eclipse is unique, and so
such a scientist.
I know.
Want to do
that
a
is
little
my experiment. How many data points can I get? But not just that. We're hearing everything about the heliophysics big year, and so it kicks off today, and that total solar eclipse in April will be the next event. So how many events can I participate in for the heliophysics big year?
Amazing. What about you, Kate?
I'm interested in sort of the things beyond just what you see, but what you feel, so that it's going to get cooler, and we might hear some animals.
Today, we felt that.
Yeah, and I really want the full body experience of the eclipse.
That is incredible. And I mean, today has been a spectacular day. So folks, let's check in one last time with James at our Eclipse desk to see how he's doing. James, what's it like?
Yeah, Tahira, I'm still in awe of the moment that we just had here a couple minutes ago here in Kerrville, Texas. Just a stunning view of that ring of fire here. And as you can see on our Eclipse Explorer, The annularity has now shifted off into the Gulf of Mexico, so if you're in a boat out there, you'll have a phenomenal view. But we're going to be here once again next year, April 8th, 2024, in Kerrville, Texas. I've got the path of the 2024 total solar eclipse up here on the screen. You can see it's tracking right through us in Kerrville and then affecting an entirely new area here that is going to be stretching all the way up to parts of New England, all the way up to Maine, even parts of Canada. So a really large area there as well. So definitely save those pinhole projectors and certainly keep a hold of those Eclipse glasses. You're going to need them for next year. We're going to be right back to cover all of that incredible stuff next year with you. It's been amazing tracking this today. And again, this is still moving onwards to Central America and South America. So if you're tuning in from there, you have a great view incoming. And in many parts of the country, there's still that partial eclipse. A truly awe-inspiring morning and a wonderful day for all. So thank you so much. Back to you, Tahira.
And thank you so much, James, for bringing us into the action during today's show. Gina, so wow. I mean, this was both of our first experiences. So final thoughts.
I mean, what a day. At this point, you know, I'm ready to look at those calculations for the eclipses and check out not only April, but what else can I see in the future? Because these are spectacular to
A little
see.
eclipse chaser now.
Exactly. I'll
you know?
chase them around the world.
No, and it has been so fantastic having you on today's show to
Thank
really
you.
just like help break down what we are experiencing today. And so
course.
again, thank you so much for everything.
Thank you for having me.
And folks, the action isn't over yet. You can continue to watch views of today's annular eclipse as it moves across the path by visiting go.nasa.gov/eclipse 2023 live. That live stream will continue running until 4:30 p.m. Eastern as this eclipse continues its way through Central and South America. Now, unlike today's Ring of Fire effect, we are going to witness the moon completely block out the face of the sun during next year's total solar eclipse. The sky is going to darken as if it were dawn or dusk. You can learn more about eclipses and what's in store for April 8th, 2024 by visiting go.nasa.gov/eclipses. The total solar eclipse is sure to be a rare event and one you will not want to miss. So stay up to date with sun-related events and how we are studying our star by following NASA Sun on social media. Folks, thank you to everyone who has tuned in to today's coverage of the 2023 annular solar eclipse. We hope to see you back here next April as we ring in the last total solar eclipse that will pass through the mainland U.S. for 2 decades. Now, here's how you can celebrate the countdown to April 8th by joining our heliophysics big year.
We are one of 100 billion stars in a vast galaxy.
Probably 2 million asteroids in our solar system.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal.
One of the ingredients that went into making our Earth, and one that we cannot see any other way. And it would be the first metal object that humankind has ever visited.
Studying the evolution of a planetary body is a detective story.
I think the only thing we know is that it's not going to look like what we think it's going to look like, and it's going to be really interesting, whatever we find.
Space is always more amazing than we can imagine with our minds.
You're looking live at NASA's Kennedy Space Center's Launch Pad 39A. Fueling of that SpaceX Falcon Heavy rocket should have began a couple of seconds ago for the Psyche mission to a mysterious metal asteroid. Welcome, and thank you for joining us live from the Space